Hey everyone, today's topic of the video is power. The goals of this video is I'll be able to calculate the power required to transfer energy. What is power? In physics, the power is just the rate of change of energy. It's measured in watts, capital W. Perhaps you've heard watts before, which was related to electricity, and that is what electrical energy is measured in. Electrical power is measured in the electrical energy, which is voltage divided by time. So same concept, rate of change of energy, that's what the power is. So let's look at the alternative equations here. Power is work over time, which is energy, work energy, they're equivalent, right? That's what we learned in this unit. Force times displacement is the definition of work. Force means here there is no cosine between them because force is the component of a force which is in the same direction as displacement, or in opposite direction, right? That's why we get rid of the cosine here. So power multiplied by displacement over time, or another definition from physics we want to use here is the velocity. So the other formula for power is force times velocity. With this example here, how much power required by a motor to lift 100 kg at a constant speed of 5 meters per second, and how much power is required if the motor is 80% efficient. Let's look at these examples. Let's write down what is given. Mass is 100 kilograms, velocity 5 meters per second. The formula for the power we're going to use is force times velocity. Let's begin with the free body diagram, and let's prove that the force of motor equals to the force of gravity. We're writing our net force where net force is the sum of all the forces. Remember our equilibrium problems. And F net is equals to 0 because there's no acceleration, because it's the motion with constant velocity. Therefore, we can prove that F motor equals mg, and then we can just use formula for power of force of the motor multiplied by the velocity. When we plug in the numbers, it's going to be 100 times 10 times 5, which is 5,000 watts. When the motor is 80% efficient, how do we find the power of the motor? So intuitively, the power of the motor should be greater because 20% of the power is lost, right? The actual power of the motor should be greater because 20% of the power lost due to certain effects of the environment. So we can construct the following relationship. 0.8, which is 80% of the motor's power, should be equal to actual power, from where the motor should be equal to actual power divided by 0.8, which brings us to 6,250 watts. Another example. The semi-truck carrying a trailer has a total mass of 1,500 kilograms. If it's traveling up a slope of 5 degrees to the horizontal at a constant rate of 20 meters per second, how much power is the truck exerting? So let's write down what is given. The mass is 1,500 kilograms, angle is 5 degrees, velocity 20 meters per second. Find the power of this vehicle. So the definition of power is change of energy, rate of change of energy over time. And what is the change of energy here? We have a closed system, no non-conservative forces are acting on the system, so change of energy will be change of kinetic energy plus change of gravitational potential energy. So the change of kinetic energy is going to be equal to 0 because it's moving with the constant velocity. There is no change in velocity. So the power is going to be equal to change of gravitational potential energy over time. Let's rewrite it as m times g as change of vertical distance divided by time. So we don't know the vertical distance h, but we can express it using the sine of the angle and the horizontal distance. I mean, not the horizontal, inclined distance. Therefore, if we write it as a change of the vertical distance as delta x times sine theta, we can finally get to our velocity, because we know our velocity, which is delta x over delta t. So we can substitute it into the formula and we can calculate the power, which equals to 26,150 watts. Thank you for watching. Fill out the Google form, please.